Okay, group. So we're going to talk about right triangles that are not 30, 60, 90s and not 45, 45, 90s, but just have a right angle. Okay. So when we talk about a trigonomic ratio, um, or just a ratio in general, okay, the ratios of the sides of a right triangle are trig ratios, meaning we can use sine, cosine, and tangent ratios to help us solve our triangles. And when I say solve a triangle, I mean we're going to find the angles and we're going to find the sides. Okay, so obviously right triangle has a right angle in it. But our other two angles, one of them will be labeled theta. Theta is the angle, it's almost like the slanted zero with a line through it. It represents the standard position of your vector. So the line that would extend from the unit circle, basically. And then the other angle, sometimes you'll see phi, sometimes you'll see the Greek letter alpha. It just depends. But regardless, that other angle, the one that's not theta, is the non-right angle that's left over once you do the right angle and you do theta. Okay? The adjacent side is the side that's right next to an angle. The opposite side is the one that's straight across from the angle. You already really know that. We've kind of been working with that anyway. And lastly, you have your hypotenuse, which will always be opposite of that right angle, right across from that right angle. Okay, so SOHCAHTOA, we've already worked with it. If we have sine, it's spelled S-I-N-E, we always abbreviate it with S-I-N, and that will always be opposite over hypotenuse. Does anybody remember which trig function is opposite of sine? I made it easy on you. Try to cross reference. Cosecant, okay? Cosecant, we write as CSC, and that would be hypotenuse over the opposite side. You would switch your sine function. Cosine is adjacent over hypotenuse. Opposite of cosine is secant, S-E-C, secant. And we would flip that cosine and get hypotenuse over the adjacent side. Lastly is tangent, which is opposite over adjacent. Cotangent would be adjacent over the opposite side. Okay, we're going to use those in an actual triangle on the next page. Okay, so if we look at, we're going to do both things. We're going to do sine and we're going to do alpha. So, I'm sorry, sine. We're going to do theta and we're going to do alpha. Let's start with theta. Okay, so the sine of theta, sine is opposite over hypotenuse. So opposite theta would be 4, hypotenuse would be 5. So we get 4 over 5. Which trig function is opposite of sine? Cosecant. So find cosecant down here. Okay, you're going to flip the fraction that we just got for sine to get your cosecant. Adjacent to theta is 3. So for cosine, we would have adjacent over hypotenuse or 3 over 5. Okay, secant is the opposite of cosine. So we would take our 3 over 5, flip it, we get 5 over 3. And then last, our tangent is opposite over adjacent, so 4 over 3. If we flip that, we can get our cotangent, which is 3 over 4. I want you to go ahead and do alpha on your own. Go ahead and do that other angle on your own. Okay, those should be your answers for alpha. You can go ahead and check those answers here quick. Any problems or issues on finding those trig functions for alpha? Okay. The last thing we're going to do is we're going to apply this to triangles. So the one thing that I need to make sure you do on these problems is that you have your calculator in degree mode, because we're going to be solving for angles, and we have to use our calculator to do that. If we're in radians, we won't get the right answer. So make sure your calculator is in degree mode. To do that, you press the mode button at the very top, mode, and then you should go down and it should look like what it says on your paper, and you should see degree there. I know I'm going to have to change mine. All right, so mode is right up here. Mine's under window, and then down, oops, go over to degree and highlight that. Make sure that's highlighted. Okay, if you want steps, if you're a step person, how to find an angle measure is there, and how to find a side length is there if you want those steps. Okay. So when we say solve a triangle, that means by the end of solving a triangle, we're going to have all the sides and all the angles solved. If you notice, the only angle we have in the first example is our 90-degree angle. So our first job is to find this missing angle x. So what we're going to do is we're going to use 8 and 6 to do that. If we look at 8, how does it relate to angle x? Is it opposite, adjacent, or hypotenuse? Opposite. Okay. What about 6? Adjacent. Okay, so we're going to be using tangent because tangent is opposite over adjacent. So how we would write this is we would say tangent of x, tangent of our angle, is opposite 8 over adjacent 6. When we're solving for an angle, okay, when we're solving for an angle, this is the only time we use the inverse of a trig function. So when you're solving for an angle only, you will do the inverse of your trig function. So in this case, inverse tangent of 8 divided by 6. And this is where it's important to be in degree mode. Okay, so we're going to go into our calculator. And we're going to do tangent inverse. So second tangent, and that'll give you that tangent to the -1. 8 divided by 6. I'm going to get 53.13 degrees. Okay, so that tells us this angle is the 53.13 degrees. Now we can get this angle here pretty easy. If we take 180 and we subtract 90 and then we subtract our 53.13, that will give us our angle. So you should get 36.87 degrees. Okay, any questions or issues on finding the angles so far? Okay, so here you have options from here. And you have to find that other side. If you have two sides, you have to find the other. You can do Pythagorean theorem. I'm completely fine with that. Or you can use trig. I'm honestly fine with either because it's math. We are all gonna do things different ways. I'm gonna go ahead and show you how to find a side just because we are doing trig. But if you want to do Pythagorean theorem, we'll do that on one of the other questions to show you. So we have two sides here. We're missing the hypotenuse. So we need to choose a trig function that has h in it. What do you want to use? We can use sine or cosine. Anybody care? Sine. Okay. So we're going to do sine. Okay. And we're going to have the hypotenuse in there somewhere. We just have to know what angle we're going to use. So if I do sine, B would be opposite over hypotenuse, right? So if I use this angle here, so if I do sine of, give myself a little bit more room, 53.13 equals opposite 8 over our hypotenuse. So whichever trig function you use, that's fine. You just have to make sure you set that up right and you use a proper angle then. We could have also done this angle, opposite 6 over hypotenuse. So there's options there. When we're solving for these, okay, we're trying to get h all by itself here. So to get h all by itself, I need to multiply by h and get that out of the denominator. So I'm going to multiply on this side. You multiply by one side, got to multiply on the other side. Then I'm going to divide by my sine of 53.13. So that will cancel out. If you put that in your calculator, 8 divided by sine of 53.13, you get about 10. Okay, there's like a decimal there. It's like 10.0000134. We're just going to say 10. We'll just call it 10. So in that case, your hypotenuse is 10. So now we have all three sides, we have all three angles. Okay, so I want to show you something, because you're not going to need to do this process every single time. You're going to see a shortcut. Here's a shortcut. Okay, if we look at our original, okay, let me rewrite that. Our original was sine was this. Okay, what you notice, hopefully, is that at the end, all I did is switch my sine function with my hypotenuse, my denominator. So all you have to do here, you don't need to solve it every single time. Just switch these guys, okay? If what you're looking for is in the denominator here, just switch these two. Put it in your calculator. You can solve it if you want, but that's the quick trick. We'll do that a couple more times here. Any questions on the first one? All right, now it'll go a little bit faster, hopefully. Okay, so on your notes, it says b minus 6. It should say b equals 6. Something copied weird on that. So go ahead and change that. Okay, this side is just 6. It's not b minus 6. It should say b equals 6. All right, so here we only have one angle and one side. So what we can do, well, I guess we have two angles, right, within 90 degrees. So we can do 90 and 40. What's 90 plus 40? 130, right? Subtract that from 180. What's the result? Hopefully you're thinking 50. Okay, so now we automatically have all of our angles there. So if you have two angles to start, pretty awesome. You can subtract to get these one. All right, so if we want to find our sides, we need to use this one. It doesn't matter which angle we use. Let's just go ahead and use 40 since they gave us 40. How does this side relate to our angle 40? Adjacent, okay? It's adjacent to 40. Okay, do you want to solve for the opposite side, or do you want to solve for the hypotenuse? It doesn't matter which one we do first. Anybody have a preference? Opposite, okay? So we're going to solve for the opposite side over here. So if we're doing opposite and adjacent, which trig function is that? Tangent. So we're going to do tangent of 40 equals our opposite side. Okay, I'm going to label it x because sometimes if we use O for opposite, we can get a little mixed up. So I'm just going to use x over our adjacent side which is 6. Okay, to get x by itself, what do I do here? One step. Multiply by 6. So in your calculator, you're going to do 6 times the tangent of 40. And you should get 5.03. Okay, I'm going to show you Pythagorean theorem if you like that method better. Because right now we have 2 sides. We're just missing the 3rd side. It's a right angle, so we can do Pythagorean theorem. Okay, it doesn't matter which one's A and which one's B. We'll just use 5.03. Okay, there's our Pythagorean theorem. A squared plus B squared equals C squared. So you'd have A squared plus B squared equals C squared. Now, how do I know that I'm solving for C and not A or B? Which side is C? Do you remember Pythagorean theorem? It's always the hypotenuse. C will always be the hypotenuse, the side that it's across from 90. Just be careful on that if you use that. Okay, so go ahead and we can put this in our calculator. Actually, you know what? I'm going to do it up here so you guys can visually see what's going on. Oh, that's okay, so if I type in that left-hand side, I end up with 61.00. Oh, 3009. Okay, to get C by itself, how do I get rid of that square? Square root. So you're going to square root your answer. Okay, you get 7, we'll say 7.83. Okay, so if you prefer trig, do trig. If you prefer Pythagorean theorem, do Pythagorean theorem. It doesn't matter to me on that last side. As long as I know that you're doing trig on other things, we'll be totally fine. Okay, questions on that? All right, next one. We have 2 sides. Okay, we're missing 2 angles here. So we need to solve for an angle. So let's say we'll solve for angle B. Okay, we have 14, which is opposite. We have 21, which is hypotenuse. Which trig function is that? Opposite over hypotenuse. Sine, right? Sine. So we'll do sine of B, because we don't have the angle. We always do the trig function of the angle. Sine of B equals opposite over hypotenuse. When we're looking for the angle, this is where we use the inverse trig function. So inverse sine of 14 over 21 you should get 41.81 degrees for angle B. Okay, to get angle A, we can do 180 minus 90 minus our 41.81. And that leaves us with 40. you want to do trig or Pythagorean theorem to get our last side? What do you want to do? You're like, it's Friday, we don't care. Okay, let's go ahead and we'll just do trig. So, it doesn't matter which function you decide to use, you just have to solve for this guy here. If we use the 48.19, that would be opposite, and we'll just use hypotenuse. We'll just make this a whole sine problem. So we would do sine 48.19 equals our opposite. I'm going to label it as x over hypotenuse 21. Multiply by 21. Put it in your calculator. So that would be that side here. Okay, last one. It's nice when we have two angles. I think they're a little bit easier. So if we'll do 180 minus 90 minus 62. That'll give us this other angle of 28. And now we just have to solve for our sides. So let's see, this would be adjacent. Let's do cosine. I'll think of that cosine. So adjacent over hypotenuse. We're going to solve for that hypotenuse. So cosine of 28. Oh, good. I'm glad I can show this again. Okay, our quick trick. When our variable that we're solving for is in the denominator, switch it with the other side with the trig function. Put it in your calculator. Okay, you don't have to do all the multiplying. Okay, and again, you can do trig, or you can do Pythagorean theorem to get that other side. It doesn't matter to me. I'm going to go ahead and I'm just going to use my 28-degree angle again. Since this is opposite over adjacent, that would be tangent. So you multiply by 25, put it in your calculator. So that side would be 13.3. Okay. Any questions for me on solving right triangles after today? Okay. There's practice sheet attached to your notes. We will probably start off Monday, what week on Monday? Tuesday, by going over some of the questions on there, okay? And then probably just the practice day on Monday. Tuesday, make it easy.